Algebra 2, what's going on, guys? Let's jump into our notes for today. We are looking at section 6, chapter 1, so 1.6, relations and functions. Make sure that everyone is on page 44 right now, okay? So we have quite a few notes to go through, but not a whole lot of example problems, so it'll kind of even itself out. The example problems will go quick, okay? So what will be vital for you guys is to make sure that you take the time to pause the video, write down the notes, restart the video, and keep up with me so that as fast as I talk doesn't mean that you have to write it all down that quick, okay? So pause, rewind, do all that stuff. All right, so there are 4 key terms that you're going to need to find in this section. The key terms are always highlighted in yellow. Find those key terms, write down their definitions, because you know that anytime a definition is given or a key term, you will have to know that because it will be in the directions. It could be in future videos that I use. It could be on the test, and you have to know what they mean. All right, so find those 4 terms. All right, one of those main ideas, though, is domain. You're going to see this word a lot. The domain is the x value. All right, so if you're thinking of an ordered pair, domain is the x value. Real quick, right here, this is what I mean. This is the x value, this is the y value, ordered pair, but those are going to obviously be replaced with numbers, okay? The range is the y value, all right? So right here, there's the domain, there's the range. Okay, now let's move into some very review basics here. These are just simple examples of ordered pairs. You got 3, 2, 4, 0, -2, 1, and then 3, 4. So those are examples of ordered pairs. And then if I were to even ask you here and say, okay, what are all the domains? All the domains are every x value. So this is what you would say for the domains. You have 3, 4, -2. There's another 3, okay? Then if I said, what are the ranges? Everything that I'm underlining in blue, these are the y values. These are the ranges, 2, 0, 1, and 4. Okay, so that's a quick review. Let's move into something maybe you haven't heard of. It's called mapping. Okay, mapping, by the way, we will still be using these ordered pairs. So mapping is basically when you list all the domains on the left, then you put all the ranges on the right, and you just draw arrows across saying this domain goes with this range, okay? But take a look at that blue note that we have there. Don't write repeating numbers, okay? So if you take a look back at those original ordered pairs, you see how the number 3 repeats itself, the first 3, and then look at the last ordered pair, there's another 3. They're both domains, but I only need to write the number 3 one time. Okay, you'll see it right here. I only wrote the number 3 once. However, finish the sentence there, just use multiple arrows from that same number. And this is how you express to me that the number 3 has 2 different ranges because it's being used twice. Okay, so you'll see that because the number 3 has an arrow going to the number 2, and then that same number 3 has an arrow going to the number 4. All right, and then you follow in the domain, go down to 4, follow the arrow, it goes to 0. In domain, go down to -2, follow the arrow, and it goes to 1. And that just coincides with those ordered pairs that you see directly up above it. Okay, so you have ordered pair is one way of showing it, mapping is the other way of showing it. And then let's move down the page here. Okay, and then simple graphing, that's another way of showing. Okay, so remember how to read a graph, remember how to actually graph ordered pairs. So I just gave you 2 very simple points there. The letter A is supposed to be at 2, -1. So if you look at the graph there, remember the x value is given first, and then just a quick review. This is the x-axis, this is the y-axis, okay? So the x value, number 2 is a positive, go to the right twice. -1 is a y, it's a negative, go down once. There's the dot for A. Okay, for B, we have a +3 for the x value, so go to the right 3 times. +2 for the y value, go up 2 times, and there's our point for B. All right. Now, some new stuff potentially for you here, talking about how do you know if a relation is a function? The quick answer is that you must have all different domain values. In other words, every x value must be different for it to be a function. Okay, that's the quick way of describing it. Now, what if they don't give you actual numbers? What if all they give you is just the picture of a graph? Then you're going to use what's called the vertical line test. And there's a chart on page 46. I want you guys to look at that chart. Probably go ahead and copy that chart down, because that chart tells you just by looking at a graph, you can tell if it's a function or not. You see the first graph has that wavy line. If you draw vertical lines going through that graph, you will only hit that wavy line one time. If you only hit the line one time, the answer is yes, it's a function. But take a look at the other one. It looks like a V, but on its side. Okay, if you draw a vertical line through that graph, you're going to hit that graph twice. Once at the top, once at the bottom, because with one vertical line, you hit the graph twice. It is not a function. So it would be no, not a function. All right, perfect. Covered all the notes right there. Let's jump into the example problems. All right, CIO. Whenever I write that, that stands for check it out. And those are the check it out problems. So go to page 44. Number one, CIO, check it out. Number one is on page 44. Okay. So they give you a graph, they give you points on the graph, but they don't tell you the ordered pair for those points. Okay. So you're going to have to figure out the ordered pairs. I'm going to go through 3 of these points with you just to save some time. Okay. So let's take a look. Go to the furthest to the left and then that high point. All right. That furthest to the left high point, if you look at the graph, you are at -2, 2. All right. Now, again, on this, they don't give you the numbers, so you have to come up with the ordered pairs. So look at the graph. That's the point furthest to the left. Now let's move 1 point to the right, and you are at -1, -1, and then move 1 more point to the right, and you are at 0, 0. Okay. Now, by the way, does everyone know what 0, 0 is? That is the origin. That is the center of every graph right there. Okay, so now they ask us give the domain and give the range. Just for these 3 points, that's more than enough information for us here. So remember, every x value is the domain. So for domain, I'm going to put D colon -2, -1, 0. Those are the domains. Then for range, let's put R colon 2, negative. Oh, and you know what? I realized, quick mistake. Some of you may have already found this. Let's erase. That should not be a negative. All right. Some of you may have been confused, like Mr. A just messed that up. I did. Caught the error. All right. Let's move on. So that would be a 1. Let's erase a little bit more here. So close. All right. 1. And then the last thing, 0. That would be the ranges, every y value. Okay. So that is the first example problem. Now let's take a look at page 45. We're going to do 2a. By the way, that's the check it out 2a. We need to determine if this relation is a function. So how do we do that? We need to look at what are the x values and what are the y values. Well, they don't explicitly say this is x, this is y. They say here's your size and here's your price. Now, how do we determine which one represents x and which one represents y? The x value is going to be the number that affects the other value. So here's what I mean by that. Does the size of shoe affect the price, or does the price affect the size of shoe? The size of shoe. All right, so the size of the shoe affects the price. So we would say that size represents x. Okay, so for this example, size that is X. And then price, that is Y. Okay. And let's do a quick review here at the notes. What is it right there? For a relation to be a function, all the X values must be different. Okay, let's scroll back down, take a look at 2a. For every X value, I see a 7, I see an 8, I see a 9. Those are all different. So what is the answer? Yes. Function. Boom, there we go. Let's move on to 3a. Go ahead and turn the page. I'm on page 46. Okay, 3a and 3b, last example problems. This is all about the vertical line test, okay? So you're given a graph, you have no clue what the actual ordered pairs are, and it doesn't matter, okay? Let's change the color here. All right, so if I draw a vertical line, I hit the graph one time. I hit the graph one time. I hit the graph one time. Okay, so for 3a, this is yes, that is a function. Okay, let's do the vertical line test for 3b. All right, I hit the graph one time. I hit the graph one time, but it's this part right here. If I hit that point and keep going down, I will hit a point on the other line. So that's actually 2 hits with one vertical line. So it's because of this point right here and this point right here that the answer to 3b is no, not a function. Okay, guys, that's it. That covers all the notes for section 6. Thank you very much. We'll see you in the next video.